Hello everyone. Welcome to this e-sharing video session. Today, I want to talk about the application of computational fluids dynamic or CFD in the food industry. Here, we will briefly discuss on 4 subtopics. First, what is CFD? Second subtopic is common CFD application in industries. The third one, the process of CFD, and last but not least, a few application examples of the CFD simulation in the food industry. Let us go to the first subtopic. Now, what is CFD? CFD is the acronym for Computational Fluid Dynamics and, as the name suggests, is the branch of fluid mechanics that makes use of computers to analyze the behavior of fluids and physical systems. Using CFD, you are able to analyze complex problems involving fluid-fluid, fluid-solid, or fluid-gas interaction. Usually, velocity, pressure, temperature, density, and viscosity are the main properties that should be considered simultaneously when conducting a fluid flow process. The Navier-Stokes equations is the broadly applied mathematical model to examine changes on these properties during fluid flow and thermal interactions process. The Navier-Stokes equation is derived from the conservation law of mass, momentum, and energy, which are in form of partial differential equations and cannot be solved analytically. CFD solvers transform these laws into algebraical equations and are able to efficiently solve these equations numerically. With computers, we can use it to store large amounts of numerical data and to perform fast operations on these algebraical equations. Here, we have a real fluid flow in a pipe. To evaluate pressure difference, we can transform it into CFD model analysis and evaluate the pressure fields inside the model. Now we go to the second subtopic, its application in industries. Here are some of the most representative industrial sectors leveraging the power of CFD analysis. The automotive industry makes use of CFD for many applications, with the most important being vehicle aerodynamics. In the aviation industry, the main application of CFD is also aerodynamics, with the aim of optimizing the lift or drag ratio and to study instabilities. CFD also can be used to simulate ship and offshore structures for hydrodynamic performance in marine industry. In the electronic industry, CFD is used to study the performance of the cooling system for the component on electronic board. And for the healthcare, we can use it to simulate the respiratory droplet from sneezing or cough spreading in the surrounding. Now, going to the third subtopic, the process flow of the CFD analysis. Here I will explain a typical process flow or process step involved for conducting a CFD simulation. A CFD analysis basically consists of the following phases. The starting point of this analysis is to construct the product or process model in 3D CAD drawing tool. We have to create a closed flow volume. Then, the geometry of the model is split into small basic shapes known as cells. The set of all cells is known as the mesh. After that, in order to run a simulation, we need to make a choice between several flow solvers, each of them suitable to solve a specific physical problem, for example fluid flow or heat transfer solver. We also have to specify the type of materials, the initial values, and boundary values of the variables. When all the input is there, the computer starts running the simulation, which typically takes from a few hours to a few days. Finally, the obtained results are visualized and analyzed. The obtained results can be, for example, static or moving pictures or graphs. Analysis can be made and conclusions can be drawn based on the obtained results. Here we have a simple example where we want to simulate the cooling of the water in the cup using 2 ice cubes. So we construct the volume of the water and the ice cubes. Then, we can do the meshing by splitting the whole volume into a number of cells. We need to specify the suitable solver for the physical problem in this case. So we select the fluid flow and convective heat transfer solvers. Additionally, the initial value of the temperature and velocities of the water and ice cubes need to be supplied. And also the properties of materials are needed, such as the density, viscosity, specific heat capacity, and etc. There are many CFD software available to run the simulation. Here is a list of the most used in industries. We have ANSYS Fluent, COMSOL, Star CCM, and OpenFOAM. Lastly, for result analysis, we can evaluate the temperature changes of water with time. We can see how the water temperature decreases in the cup as time passes. Now we go to its application in the food industry. The simulation can be applied for mixing process, for getting dispersion of two fluid, powdery, and gas ingredients, and for obtaining a homogeneous final product. The analyses will show the expected mixture quality after the simulation process, as well as the areas of the design where stagnant zones are likely to occur. Thus, this can be used to quickly suggest improvements in construction and operation parameters. The next application is in food packaging. This can be used for designing packaging box for fresh fruits. The airflow and temperature distribution in the packaging can be analyzed, and the design can be changed to get a homogeneous airflow and temperature distribution. Here we have an example for cold airflow and temperature distribution for packaging box stored in a cold storage place. Next is the application in the thermal treatment of food product, which is the sterilization process. Here we can evaluate the temperature of the canned foods to ensure homogeneous cooling, and heating for uniform product treatment to ensure a consistent quality of products. Using this analysis, we can track the cooling region or slowest heating region. The next application is for heating in a heat exchanger. Here, for example, we have a heating process of olive paste in a tubular heat exchanger. We could see how the temperature changes within the heat exchanger and the viscosity distribution of the paste inside it. The last one would be the application in food packaging. This is for carton milk design evaluation to minimize the effect of splashing when pouring the milk. Here, the pressure distribution near the opening is analyzed to get suitable design of the carton. Based on the analysis, the low pressure at opening can give minimal splashing effect during pouring. And also the turbulence formation can be depicted and evaluated. So, to conclude, application of CFD in the food industry will benefit the understanding of the dynamics and physics of a food processing operation, and thus aid in the optimization and design of existing and new processing equipment. We could see that there has been considerable growth in the development and application of CFD recently in this industry. However, this does not mean that we can neglect the conventional experimental method. Because CFD analyses is approximation of a real physical solution, it should be noted that these CFD analyses cannot fully exclude physical testing procedures or experimental testing. But for verification purposes, tests or experiments should still be performed. So, we have reached the end of this session. Hopefully you will find it very informative and interesting. Thanks for watching, and I hope to see you in another video session. Take care and goodbye.